it's a long story. We've invented a method by which we can greatly accelerate the settlement, growth, survival, and resistance to stress of all marine organisms. We use low-voltage direct current electricity that can be provided by the sun, the wind, the waves, or tidal currents. And that way we're able to keep coral reefs alive where they would die and grow them back in a few years where there's no natural recovery. It works with oyster reefs, it works with seagrasses, we grow beaches back, and we can save whole islands as well. So it's an example of a very innovative technology for restoring ecosystems, which is only one example of many. We've published a book on that. We have another book coming out next week, which is on increasing the carbon in soil, on soil fertility restoration and removing CO2 from the atmosphere and storing it.
But so you put electricity into the water?
Yes, low voltage direct current that we can make from solar panels. And what that does is that creates the conditions that makes everything grow faster, because you, like everybody else, you make your energy from a small voltage difference between the inside of your cell and the outside world. And we're stimulating organisms to make energy naturally that way.
Wow, and how widely is this particular technique used?
It's only on a very small scale. We've been working for 25 years with it all over the world, but we've been working with no money at all. If people were using this, we could save our reefs and we could save our low-lying islands, but it's only been used on a very small scale.
Right. I mean, obviously, I suppose if the initial pollution's not there too, then that's that would save them as well, I guess. But where can this be used? I mean, where has it been used already? Give us an idea.
We've done about 300 projects all around the world, mostly in Indonesia, but actually can be used in any. We grow fisheries habitat back. We grow oyster reefs back in cold water or salt marshes. We can make them grow seaward, so we're able to protect any kind of coastal ecosystem and restore the fisheries and shorelines. Yes. Well, actually, let me just say one thing here, and this relates to UNFCCC, and that is that UNFCCC, as it is now written, is basically a death sentence for coral reefs and low-lying islands, because the so-called 2-degree acceptable limit, we're already at the maximum limit of what corals can take. They can't take any more. We're at the maximum level of sea level that small islands can take. They can't take any more. So when people talk about a 2-degree acceptable limit, that means violating the very fundamental goal of the UNFCCC, which is to protect our climatically sensitive ecosystems or life support systems. But if we say 2 degrees is acceptable, that means we choose to destroy the major resource of over 100 countries and all the low-lying coasts. Now, this is something people don't seem to understand, that that's not acceptable because it's not in agreement with the goal. Furthermore, I mean, it's far worse than people recognize, because when people say 2 degrees, that's what IPCC projects will happen in 10, 50, or 20 years from, or 100 years at the most. But see, actually, I'm also an atmospheric biogeochemist. My PhD is in atmospheric chemistry. And the fact is that IPCC has seriously underestimated the long-term impacts of climate change. When they talk about 2 degrees, that's only the initial slope, which is going to continue many, many times further. So when people say 2 degrees, that's in 50 years. Be another 2 degrees in the next 50 years, another 2 in the next 50, and so forth. So we can use the actual ancient climate data. We have a 1,000,000 years record from the Antarctic ice cores, and we can actually figure out what the CO2 caused temperature and sea level rise would be. And for today's CO2, which is 400 parts per million, the equilibrium temperature is 17 degrees C warmer than today, and the equilibrium sea level is 23 meters higher. Now, that takes a few thousand years to reach that. It won't happen in the lifetime of the people who signed these treaties, but we have committed future generations to that increase. And so people are talking about fictitious goals. It's not scientifically sound. And the major problem is that there's 6 times more carbon in soil than there is in the atmosphere, but soil is not included in UNFCCC. People don't need to account for it. Now, if we increase soil carbon by 10%, we can store all the excess CO2 and solve the problem. It's the only way we can do it.